begin the talk. So today I'm going to talk about iPython and the iPython notebook. I attended ChiPy a couple weeks ago in Austin, and it was a large focus of not only the convention, but also of the scientific programming community. So who here has heard of iPython? All right, everybody. Who here uses iPython on a regular basis? All right. And for a lovely iPython sticker, who here, closest to the nearest 50, can tell me how many lines of source code the original iPython contained? Any takers?
12.
Rounded to 50. Rounded to 50.
50.
No.
650.
What is it? 650? No.
350?
Not 350, a little lower.
200.
250. So the original iPython contained about 250 lines, I think 259 exactly, lines of source code, which is pretty cool because it's come quite far. So who here actually runs the iPython notebook? Just a couple people. So the iPython notebook is an extension, but if you originally got started with iPython, you might come to a terminal like this and just type iPython. And you get dumped into an iPython terminal. And you could print things. And this is really cool. It allows for a lot of nice interactivity. But they've recently come out with the iPython notebook. And I think that's really taking iPython and scientific computing by storm. And so if you want to... And so if you want to run the iPython notebook, you just type iPython and then notebook afterwards. It'll run. It'll open up a browser window with notebooks in it. Now you can create some. I have some in here for the talk, which I will use now. So one of the nice things about iPython is it allows for mixed languages. And so Fernando Perez gave a talk, his keynote, where he introduced using Julia within iPython. Oh. See if we can get sound here. Oh.
And so we're pushing now beyond the Python language itself. For example, we have now support for Julia, and I know some of the Julia guys are going to speak.
So like if it's hard to hear, he's basically going to run Julia code.
Started just a couple of months ago, but now, thanks to a lot of work that the Julia guys have.
He's basically going to run Julia code from within iPython, calling matplotlib, which will return iPython, or which will return Python variables. And so they're working back and forth seamlessly. And one of
Executes, for example, mix the code from Julia.
And one of the problems that I think people in the scientific community have is that they need to deal with multiple languages. And so iPython allows you to work with a number of languages through what are called magics. And so there's magics for Perl, there's magics for Ruby, there's magics for R. And here's a quick demonstration. We have a little bit of Ruby code right here. We have a little bit of Ruby code here, which is going to come to a Ruby output. Okay. Sorry about that. So we're going to generate some Ruby here, and we can take that, and we can turn it back into Python. And so if you need to work with different kind of languages in your workflow, iPython Notebook supports that. Now one of the other nice things about iPython in general, a lot of computing today in general, is that there's a lot of cloud-based computing solutions. And so, who here is familiar with continuum analytics? Who here is familiar with Python Anywhere? So these are two companies that allow Python-based computing solutions in the cloud. But specifically, they allow a lot of the mathematical and scientific libraries. So NumPy is available in there. So if we come here to Python Anywhere, we can start up an iPython kernel right here in our browser. And we'll see that it loads, and it'll give us the iPython interactive console, which is really kind of cool because if you're a teacher specifically, you want to get students up and running. You don't want to have them deal with installing things. And it's all right here. And a lot of the familiar things that you've come to know in iPython are available as well. So we can list a directory, we can cd into Dropbox, we can see what's available there. We can run things, it's shareable. Now, Continuum Analytics has a similar solution. Theirs uses the notebook. And so this is another great way to start using iPython. Now, one of the big problems with dealing with scientists and dealing with any kind of numerical computing is that you always have to get data in and data out. And sometimes it's not always easy. There's not always necessarily an easy API. Here we have this load magic, which can take a file right there and load it right into the iPython notebook. We can run that, and we can do computation on that. We can plot it, and then we can write that back out to a file. And so we can do all of this stuff. We can list our directory. We can load all of this code. And that makes it really, really convenient to do scientific computing. One of the other really cool things about iPython is that you can embed it. And so I'm going to run a little short demo here. So So this is going to run a little script which downloads off of Yahoo Finance some recent historical information. So this is just some quote price and some data. But what if we want to do something else? So now instead of the PE and all this stuff, we want to run some code on this. And so let's take a look at this. We have a data frame. Where did that come from? Well, oops, put the E on there. So here's the code for that. You can see that we come down and we have a data frame, and we just run this little embed, which comes from iPython embed, and it drops us down into the terminal. And so now I can do kind of cool computation on that. I can print its close prices. I can do a lot of interactive computation, which is one of the things that iPython is really, really good at, is being able to work with your data interactively. So one of the other cool things is that because you're running things in the iPython notebook, which is technically a browser, you don't have to do things with just plain text anymore. And so I kind of stole this from a talk that they gave, a tutorial. And so we can generate some HTML, and we can render this string as HTML right here. We can take some more HTML, and we can render some JavaScript, and we can pull in D3 right here, and we can create a cool D3 plot. This is stolen from Brian Granger, this iPython in-depth tutorial. Now, this is maybe something that a lot of people are familiar with. You can run bash commands from within iPython and within the iPython notebook. And this is really cool. So we can get a calendar of today's date. We can take a string, we can set it to a variable right here. We can see what our current directory is. We can list that. I'll remove that. See tree. File should be removed. We can take help on a function. And so say you use wget or curl or something like that in a lot of your everyday workflow, you can use that here. So we're going to call wget from within the browser, which is as if you would run it at the command line, but we're going to call it with apple_csv, which is the variable that I defined way up here, this long string, to download all of this Apple stock data. And it's going to run. And we can see our tree again. We can list our files. We can do everything that you could from within the command line within the notebook. And this makes for a lot of seamless interaction. You don't have to toggle back and forth within things. If you have a bash script, you can run it, which is super convenient. So one of the other cool things that I like is the documentation. Who here likes to read documentation? Don't everybody raise your hands at once now. So we can document things really easily. So here's a simple plot, but really this is all you get. But what if you want to see what kind of things that you can call that start with title? Get title, set title, title offset. And so if you are unfamiliar with an API, you can really just use a lot of iPython's internal way to call documentation. And it's really easy. You just add this little question mark after it. It'll call up the doc strings for that. And so let's take iter tools. We can see all of our documentation down here. Now, I really like it because if you're a user of Pandas, Pandas is an incredibly large library with a lot of, how do I want to say, kind of small gotchas. You don't put things in the right way, or you don't know the right parameter to call. It can really get hairy, and so I'm always looking through the documentation. And so you can see that just by calling with one question mark after that. And if you want to see the source code, you simply add 2 question marks. And now it drops us down into the source code if you really want to see how things are being called. Now, I've covered some of the tab completion things a little bit, but I got to say that when I first started out learning Python, if it wasn't for iPython and the tab completion, I think I would have switched to something else. But it's really, really cool. And one of the nice things about it, and to use another Pandas example, is that you can call tab completion, you can call tab completion on arguments. So if I hit tab, and this is kind of small, we can see how are we going to merge these 2 data frames, inner, perhaps we could use outer, on, you want to use the left on, what column you want to use. Is it going to be an index join, or is it going to be on a particular column? And these things are really hard to remember. And so tab completion really helps you to do this. But let's say that we're going to join left on. You can hit tab, and it fills that in. So a lot of my workflow involves typing in open parentheses and then tabbing a bunch of times to see what's available for me to put in there. And that's how I interact with a lot of stuff. But what's really, really cool about tab completion is they have something that's called greedy tab completion. And so I think it's a kind of fitting name. So we're going to do a little reading of the regedit for Python. And so we're going to pull it into LXML. And we have all of these elements here. Okay? Now I have no idea what all these elements are, but they're obviously linked with the class of title. Okay? Now I can take the first element in our list, indexed by 0, right? And I can see text content, okay? But what about the second one, right? So, oops, I'll change this to false actually. So if I go back here, I tab complete, and it doesn't really give me any options. It just gives me these .gets. But under this config option, we can configure our tab completion for greedy. And here's a few other of the configuration options for iPython. So we're going to change greedy to true, and we're going to run it. And now we're going to tab complete on this, and it's going to give me all of the methods that are available. It's actually running that little bit of code and evaluating it and returning the methods to me in this little list here. So let's take text content, right, and let's call that. Let's tab complete on that method call, right? So this is going to return a string, right? Let's do upper, and I can run that. I can run that as lower. And so this is an excellent way to interact with all of your computing. If you don't know necessarily that things are in a list and you want to start exploring them and interacting with it, this tab completion greedy is awesome. Now, performance. Perhaps premature optimization is the root of all evil. I don't know. But who here has used Timeit? A couple of people? So one of the nice things about Timeit is it's actually in the standard library. So we can call it from within our code by just importing Timeit and running these things. So let's try an example out. I'm going to copy this. I'm going to paste it here, and I'm going to run it. And one of the nice things about iPython that makes computing so seamless is you see the 3 chevrons, right? That's what we use for at the command prompt. iPython strips that out. So you can just copy and paste code from a lot of different places and just run it without having to worry about things. But I don't want to go through all of my code and start putting these little Timeit things in there. So iPython has that built in. So let's create a function. And this is going to be a slow, just multiplication function within Python. And I'm going to call Timeit. And we can see that it runs. So if you have a little bit of code that you're testing out and you want to see, well, how fast is that? How much time am I spending on that one particular item? You can call it. And so let's compare it with NumPy. We can see our NumPy's time's quite a bit faster. But now we're just calling Timeit here on one simple function. iPython has something which are called cell magics. And so these blocks of code that I'm running are called cells. And so if you use 2% signs, that's a cell magic. And that's going to apply that magic to everything within that cell. So we have 3 different lines of code here that I'm going to call all with the Timeit. And so we can see how long that piece of code takes. And so I think that's a great tool when prototyping your code, you want to test some things out to see how long things take. Now, run. Run I used to use a lot. And I used it a lot because at the time, the iPython notebook didn't exist. And what made it really, really cool was that you could take a script and you could run it from within the command line. So let's jump down here. Let's go back into iPython. And so you could type %run. And I'll show you, oops. Thank you. So there's actually a lot here within the help. And just as before, we can just add a little question mark after it to pull up the help. So you can see that you can run code with a lot of different options. And you can type %run, and then now let's see what kind of files that we might want to run. Let's see, oops. Let's run our little see if that runs. So this is going to run, right? And I used to go kind of back and forth. I'd have a code editor up. I would percent edit. I would edit my code here, right? I would maybe add some things. And I would come back here, and I would just run it. So that was a really nice workflow. I think that the iPython notebook has really solved a lot of those problems because it's kind of interactive. You can go, you can type code in a cell up here, and you can run it, and then you can go back and forth. Your code doesn't execute necessarily in order. So if we see that we have these numbers here, in2, in3, those give the order of inputs within the iPython kernel. So we can actually, let's take y equals, so we can actually try to run something before we've defined it, and define it down here in our code, hit Shift-Enter to run that, and run it up here. So it allows really nice interaction with your code. You're running things in different cells, you're moving around, you can move cells up. So if I have this, I can move this cell up, and then it would run as normal. So a lot of the problems with dealing with a Python interpreter, and even the iPython interpreter at the console, is that it's not necessarily a non-linear workflow. And so the iPython notebook is excellent for that. Now, I think this is really, really cool. And this was part of one of the points made at ChiPy, which was reproducible code, being able to create a bit of computation and share it with others. And so the iPython notebook really allows for that. And they have these markdown cells. And I've been using them throughout the talk. And this is what a markdown cell looks like. And this is what a code cell looks like. And we can simply toggle between the two with a few, let's see, cell type. We can change it to a heading. We can change it to markdown. And now this is a markdown cell. And so it allows you to document your code. So when you're working with other people or sharing things, we're going to collaborate with a large group, you can have your documentation right in there. You can put images in there. You can put links. And so it's really, really cool. I can click the iPython documentation. If you have a certain part of documentation that you want to show, they can just click on it. You don't have to add other things. And so that's really, really neat. And now they have this notebook viewer. And the notebook viewer is really cool because it's a little web service that you can run which will allow you to share notebooks. And so I've created one as a sample here. So this is just a simple GitHub repository. And I have this iPython notebook, which is actually a bunch of JSON. Okay? And this is publicly available through the link. And so we can share this. And this is shareable right here. I could take this link, copy and paste it in email, exchange it over IM, and people can have it, and they can see all of the work that I've done. Here, it's just a bunch of videos that you should check out. Oops. With the tutorial from their SciPy, as well as a lot of the PyData stuff. And so all you would have to do is come over to their little notebook viewer, submit a publicly available URL, and it just pops up here, available for you to share with your colleagues. Lastly, iPython's big. Like, I'm always forgetting what to do and how to run things. So this is probably very, very useful if you're starting out, this quick ref. Just type %quick_ref, and it gives you a reference of all of these different features within iPython. So it tells you about the history, how it caches input, how it caches output, all of the different magics that you have. If you think there's something that you're doing on a repetitive basis, and you do it a lot and it gets really, really annoying, chances are it's been solved with iPython. And so if you look at the quick ref, you'll probably find it there. And so I encourage everyone to take a look. If you haven't started using it, I think you should start tomorrow. As one person said, if you're not using iPython or the iPython notebook, you're doing it all wrong. Thank you.